include the 1994 National Young Scientist Award from the Ministry of Science, Technology and Environment, or STEAM, in recognition of his research in quantum optics, and he was also named as one of the top research scientists in Malaysia by the Academy of Sciences Malaysia in 2017. I think I remember when I was the director of CITA in the years through 2006 and 2008. That was when our office was adjacent to the cyberspace security lab in College of Engineering. That was when we have not moved to this building. So I remember at that time, the university launched that research project, which is a multi-million project funded by MIMOS. Is it, Prof? And I remember there was like an optical laser machines, next to our office, and there was some research work being done by some of the local students, even some foreign students. I think there was some Russian scientists there. So I think there was something going on in the lab at that time. So I think probably there was some research going on probably researching into quantum state of qubits or something. Using that optical laser machines. And that was way back more than 15 years ago. So I think, which means our institution has been involved in, the futuristic study then in quantum technology for a long time. So it's not something new. And I think Prof. RIDZA has brought it to our institution, which we regard as the institution of the Ummah. So there must be something very significant about this research and also the knowledge about quantum technology. I think now we have seen some successful implementation of quantum computers. And I think the application, the potential of this technology is so vast, with I think we are going to be more familiar with new architecture, technology, computers that uses new architecture, not like the classical ones that we use today. And I think the potential is so big, but the world problem is also so big. So maybe with the quantum technology, there are certain things which, set of knowledge that can help to, elevate our position as a Muslim Ummah, as well as in solving the problem of humanity. I think in all fronts, including social, economic, politics, and I think the world needs a lot of solution. And so hopefully this is the time for our kuliah, maybe to start looking into this area, and hopefully, Prof. RIDZA can also help us in, providing the leadership, and also to start off with what you can do, inshallah. I think there are a lot of new areas that we are going to venture in and try to learn from, inshallah. So I think without further ado, because we only have 1 hour, so I would like to give more of the time to our speaker today, inshallah. So the floor is yours, Prof.
بسم الله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على أشرف الأنبياء والمرسلين سيدنا محمد وعلى آله وصحبه أجمعين الحمد لله رب العالمين. السلام عليكم ورحمة الله وبركاته. Thank you, Prof. Abdul Rahman, for the very straight to the point introduction. Prof. Lee, the Dean, fellow colleagues, I really hope that we can have a very good discussion. I'm not sure about the online participants, but at least with the people present in the room today, inshallah. Because I'm going to take you, how I see it, through a bizarre journey. Because this is something I believe is the way forward. And what I meant by this, perhaps I can highlight it in about for 30 to 40 minutes, so then we'll allow for discussion. All right, so the title given is Quantum Technology and Ummatic Excellence. The problem with the communication with the remote. Sorry about that. Little bit of a hiccup there. Trying to communicate with the remote. We did the testing just now for the information. This Murphy's law. Oh, you want to move it for me? Still cannot. Okay. So basically, this is the outline of my talk. So the first thing, what is quantum technology? So you need to digest that. The next is, what is the principle of least action? Very related to what we are going to talk in terms of quantum technology. And then, how realistic is this quantum technology? We do have quantum computers today, but we're talking about off-the-shelf kind of thing. Whether we really have the opportunity within our lifestyle to enjoy this quantum technology in that real sense. And then how can technology contribute to Ummatic excellence? So I'm going to try and make a connection there. So I'll touch a bit on what is meant by a moonshot project and some conclusions. So this is how we're going to go through this morning, inshallah. And if we look at this slide, what I'm trying to say is every time the technology is introduced, it will affect the way we behave. We don't have to talk about our digital age right now. Even though we already gone through a lot of things, let's take this bow and arrow example. Bow and arrow. So if you have the hunter and the prey, right? So last time, without the introduction of the bow and the arrow, it's a form of technology, by the way. Right? So now you can actually bring yourself further away from the prey instead of going into the prey to catch the prey or kill the prey. So this technology allows us to do something in, can say, remote. Also, if you want to put in some kind of trap, also there's a form of remote kind of activity where you can catch your the prey. And then if we look down there, the context, the meaning of a warrior. Today, we do not know what is a warrior because you use the drone and you play with the stick or whatever, and you see people dying. So who's the warrior? But last time we see the concept of warrior, for example, Maswa, Badar, and so on, they're really something close to that, understood what it means to be a warrior. So with the introduction of technology, things begin to change. And in order for us to stop our grandchildren, I have grandchildren, to make a lot of noise, okay, we can put your smartphone on the table. So they watch the Upin and Ipin. These are things that actually change the behavior and influence our generation as well. So what is the ultimate purpose of technology? Technology is supposed to help us to solve problems. So whether we are in physics or in computer science and so on, supposed to solve problems. But ultimately, the purpose of problem solving or solving problem is actually to fulfill our obligation as Abd and Khalifa, vicegerent, and also the slave of Allah subhanahu wa ta'ala. Yeah, we are supposed to serve Allah subhanahu wa ta'ala. We are supposed to come up with a coding, whatever. Don't forget, it's supposed to do the ultimate kind of purpose, serve Allah subhanahu wa ta'ala. Because everything here on earth is transient, temporary. We have to go towards something that's more permanent. Okay, so in this ayah, for example, it reminds us, yeah, the vicegerents on earth elevated some of us in rank over others, so it may test us. What he has given us, surely Allah subhanahu wa ta'ala is swift in punishment, but is certainly all forgiving, most merciful. So when we talk about quantum advantage, This phrase is quite common now in the literature, quantum advantage. There's also another phrase called quantum supremacy. It's rather racist. But people use quantum advantage. But of course, they try to give a definition. This is the meaning of quantum advantage, the meaning of quantum supremacy. But either way, it's trying to tell us that you have a certain significant advantage over the conventional other technology, which is not using quantum approach. So the picture that you see on the left of the slide, that is called a Keeble balance. Okay, the Keeble balance is meant to give you the new measure of the kilogram, standard SI unit for kg. So you use the quantum Planck constant, quantum technology. This is in the sense of quantum sensor. So quantum technology, usually we can associate with three pillars or three things: quantum metrology, quantum sensing, quantum communication, and quantum computation. We have three branches coming from quantum technology, the main three branches. So the left side of this slide is involved with quantum sensing. That gives us the new definition of the SI unit for kilogram, mass. The center picture is the quantum secure communication, quantum cryptography. Okay, that two boxes originally built in Switzerland, ED Quantic. So that's supposed to demonstrate how secure communication can go through optical fiber for some distance, so that Alice and Bob, two communicating parties, can communicate securely using quantum technology. The last picture there is one of the latest technologies. We are using essentially the vacuum, which is almost nothing, to move a pair of 40-kilogram mirrors. Then you need to be bizarre, yeah? We are using essentially a vacuum to move a pair of 40-kilogram mirrors to detect gravitational waves. So that was making news a few years ago. How do you make use of vacuum? The way to think simply is because vacuum, we call it vacuum fluctuations. So in vacuum fluctuation, you amplify this. Eventually, you are able to move the 40-kilogram mirrors. And these mirrors are subjected to the incoming gravitational waves. So with the detection of gravitational waves, making headlines, you can actually observe the signal coming from black holes. All right, so this is very important. Atomic clock, you can buy this, maybe cheaper now. SD about 2000. It's already out there in the sky, many of them for GPS purposes. You want to go one place to another, you don't have to pay currently anything, it's already out there. But they're using this concept, atomic clock. Atomic clock means quantum technology. Okay. Then quantum computing, if you have quantum computers, these are some applications you apply in terms of cybersecurity. You can apply it in chemical engineering, you can apply it in banking, finance, you can apply it in advanced manufacturing, coming up with new drugs, healthcare, and blah, blah, blah. So these are examples where you make use of something within a mathematics called combinatorics, some kind of computation kind of thing, and you can apply it to these, at least four of these things. So this Canadian quantum computer has been there for some time, different from the quantum computer developed by IBM, Google, because they are using a technology called quantum annealing process to find out the optimized kind of solution, rather than the one that's being used at the same time, IBM on that. Has been there for some time. So when we talk about quantum technology, as of today, moving forward, we are now moving into the second generation of quantum.
Second village.
Okay, quantum technology. The first quantum technology, alhamdulillah, we have all of them. The PC is like here, Okay, that camera, without the first revolution in quantum technology, there's no semiconductor means nothing. Semiconductor means the first quantum revolution means you discretize the energy level. So in semiconductors, essentially you have discrete energy levels, separate energy levels. You have electron here, electron there. There is a band gap. Okay, so very simple idea of quantum physics. You discretize the energy level. Classical physics, they think of electron circling the center, the nucleus, in all possible energy level, which means continuous energy, but that fails. Okay, if it is actually, imagine circulating, so making the circulation around center, by definition, if you have an electron, a charge, and it's actually orbiting, it is always continuously accelerating, although it has constant speed. Because the definition of acceleration is you have the magnitude as well as direction. So if it's always going like that in a circle, the direction is always changing. Even the speed is constant, the direction is always changing. So by definition, I have acceleration. So the classical physics tells us if you have an electron orbiting a center nucleus, eventually it will collapse to the center of the nucleus because the negative electron is attracted to positive proton or nucleus. So that doesn't happen, otherwise it don't exist. Everything collapses. So the first revolution is to that important simple step. Electrons cannot occupy continuous energy level, so they discretize finite energy level, like a ladders. Step one, step two, step three. So that is the first quantum technology. And alhamdulillah, it affected us, the Ummah as well. That's the most important. And everything, this kuliah also now, is because of the first quantum breakthrough. So the second quantum technology, the second generation, is how do you manipulate, you exploit single electron rather than a group of electrons. Like semiconductor, you have group of electrons. You are not manipulating at a single electron level. So the first generation, we are talking about transistors. Transistors made up of semiconductors. And semiconductors, a lot of electrons, they work as a group. So when you move to quantum computing, the one that I showed just now, they are moving to exploiting electron, for example, one by one individual particles. So it's very delicate. That's why you can see it's so difficult to come up with this technology. Okay, so the first one is discretizing the energy level, and we have benefited a lot, and we are still benefiting from it today, semiconductors and so on. The second generation now is human beings want to make these individual quantum bodies or objects, how we can exploit it to take it to the next level. So that is quantum technology, the second generation. So to do that, you need this thing, basic building block of quantum information. We call it qubits. Qubit is a short form for quantum binary digit. In classical information, we call it binary digit, BIT. Okay, and quantum, we call it quantum binary digit, but that's a mouthful, so qubit. Okay, instead of rabbit. Qubit. So qubit, if you look at the left side of the screen, that is the classical BIT. You only have two possibilities, 0 or 1. But if you look at the center of the screen here, the slide, you see that the 0, 1 from what we have from the classical version is only the north and the south pole of that sphere. Only 2 dots, 2 points on the large possible infinite position that you can occupy on the surface of the sphere. So that gives you an idea that we have all been working on something that is being restricted, which is the 0 and 1. From the point of view of the sphere, we have been exploiting only 2 points. So why are we restricting ourselves on 2 points on that sphere when Allah subhanahu wa ta'ala said that we can actually exploit all other points on the sphere? So if you can actually imagine superposition, some of us are familiar with superposition. For example, Allah says in the Quran, right? أعوذ بالله من الشيطان الرجيم ثم لا يموت فيها ولا يحيا. And hereafter you find that they are neither alive nor dead, superposition. In quantum mechanics, we call it Tony cat. The cat is envisaged to be both alive and dead at the same time, unless you make a measurement. And you call that definitely that is alive or dead. But if you do not make any measurement, leave it as it is a super state, a superposition state. Okay? So the concept of qubit is allowing two possibilities to be superposed, superposition, 0 and 1. So if you can allow for 0 and 1, so now we are moving the paradigm shift. Okay, we think 0 or 1 becomes 0 and 1. Superposition means n. Previously, classical 0 or 1 binary. Okay, so now we are moving ourselves into a realm. We're talking about 0 and 1. So you can cover all the points of the sphere. Can be both, unless you make a measurement on it. So we come to that.
I should get with the epistemology.
Yeah.
The one is something.
Yeah. So it can be both at the same time. So I'll tell you what's the difference a little bit later. So now, the next thing that will be in your mind is, okay, that is the concept of a qubit. So how do we realize a qubit? There are many ways to realize a qubit. One way is to resort to geometric optics. I think one of the easiest way to understand is geometric optics, because every morning we wake up, comb our hair to see ourselves in the mirror, reflection. It's geometric optics. So reflection there. So if you have light coming, we call it incident light, and then there's light reflected. This is the mirror. Here is you have the concept of refraction. Refraction is you look into the swimming pool, and then you see that the fish, for example, inside the swimming pool, there is one fish there, it seems to be nearer to you. There is a bending of light. Because it bends, it seems that the fish or the object in the water seems to be nearer to us. Okay, so these are what we call geometrical optics. So we make use of that concept. So you have a mirror here. So this is the cross section here. The right hand side is the cross section of the mirror. So you have a mirror, you have incoming light, and then some of it is reflected and some of it is transmitted. Okay. Some of it is transmitted. Okay, sorry, it should be this way. There's some of light coming this way, and then some of it is transmitted, some of it is reflected. So if you have a totally reflecting mirror, if it is a real mirror like the previous slide, there will be no transmitted light because everything will be reflected. But now you engineer it such a way that you do not make the mirror to be 100% reflective. You allow, for example, 50-50. 50% will be reflected, 50% transmitted, or 60% reflected, 40% transmitted. So you have partial kind of reflection and transmission. So you see this light here. On the second picture on the slide, if you have one light coming in from the left, some of it will be reflected on the top, and some of it will be transmitted to the right. So essentially, when you have some of this light going that way, some like that way, similarly here, basically you have realized a qubit. You have a superposition. Some of it is going this way, some is going that way. Some of it is being reflected, some is being transmitted. So that's a simple idea using optics to realize a qubit. All right, so next, we imagine now that we have a memory that store one, we go back to classical binary digit. One memory that can store 1 bit. And then you prepare this memory so that you have 100 memory of this 1 bit. So the first one, so all these are identical. So let's say the first one you measure the center in the slide here. The first one you get is 1, because you can only have 2 possibilities, 0 or 1. So the first is 1. So what's the conclusion? Very simple. The rest 99 will be 1. But it's not true if you go to the qubit. You prepare every one of them identically, superposition 0 and 1. Just because you measure the first one doesn't mean the 99 will also be the same. They are all mixed superposition. They are all different. Every one measurement will give you possible different kind of measurement. So that is one of the strengths of quantum technology. Okay, so whether you're in quantum technology revolution 1, quantum technology revolution 2, what they are doing essentially is not running away from information processing. Okay. The first one, you have transistors, semiconductor, information processing. So now we are also talking about information processing, but exploiting the single individual quantum objects. So either way, it's not running away from from information processing. So let me repeat, this slide is just telling us that if you go into the quantum world, the bizarre phenomena here is that even though you prepare all the 100 memories with the same so-called state, every measurement will give you different outcome. It could be 1, it could be 0. So let me remind you, first, how can a state be always be in the superposition? No, it can always be in the superposition unless you make a detection, which means you disturb. You make an interaction with the state. So you will collapse to either one of the value. It goes back to the classical value 0 or 1. So you can always have a superposition you prepare, but when you measure it, it will definitely collapse to either 0 or 1. So making it into the classical world again. Right? So as long as you don't disturb it, okay, if you have something like this, you have a cat inside a box, okay, and then you don't open the box. I'm trying to simplify the example. The cat is neither dead or alive. Unless you open and you can see with your eyes, okay, the cat is still alive. As long as you close the lid and you do not do any disturbance, it's both alive and dead.
Are we translating it to that you don't know the state?
Yes, it's about, well, I have a slide on it, it's called ignorance. Ignorance. So we are in the second technology, quantum technology, we are really ignorant. Unless we make the measurement. You make the measurement, you will definitely collapse to the classical values. If you prepare it as a 0 and 1, 0 and 1, you will either collapse to 0 or 1.
It's the benefit of the ignorance.
So this is the components of this quantum information processing system. You will need the qubits, which is the information that is going to be processed. And then you need the logic gates. In this case, they are called quantum logic gates. In the normal world we have today, they are just logic gates. Electronic logic gates, they are making use of the semiconductor, but not the individual quantum objects per se. So this, if you look at the matrices, there is a sample of mathematics to represent some of the logic gates to realize it. Okay. So you have the mathematics to represent logic gates, and you have the mathematics to represent the quantum qubits. Okay, and then you can do all this for the quantum computation. Okay, so this one, what I'm saying, normally ignorance is not a good thing, but in cybersecurity, ignorance is good. Ignorance is good because we have 3 things at least, right? what you are, what you have, what you know. It's one thing in cybersecurity. So what you know is your password. Yeah. What you have, card, in card, for example, you go to ATM, and then what you are, biometrics. So you don't share those kind of things with the other people, right? So ignorance, in that sense, from that perspective, is bliss, is good. It's not always, we say that ignorance is bad. For in the context of cybersecurity, information security is good. Yes. So now, let me go back to geometrical optics here. Making example of optics. This thing here that we see on the left is what we have shown just now. It's trying to tell that when light travels from a less dense medium into something denser like glass or water, it will bend. It will bend. So the right figure is telling us we consider a lifeguard who wants to save a drowned swimmer, not to drown. So do you think it's wise for you to go straight line? Is it good to go on a straight line path? Do you think it's a good choice to go on a straight line path? No, because if you go straight line, see, the way that you run on the beach, on the sand, and then as you go into and swim into the water, they're not the same, it's not homogeneous. So you would love to go as far as you can on the land and then swim because you're slower. So that actually is what this person called Fermat principle. In optics, called Fermat principle, around the middle of 17th century. The Fermat principle is trying to tell us that you can explain this bending of light. It's basically that. Logically, if you want to save somebody, we are trying to do something like that light ray is trying to do. Finding the shortest time to save the person drowning. Okay? So the right one is we making use of the brain. The left one is pre-programmed by God. As it goes through the boundary of two different media, it has already been pre-programmed. It will take the shortest time. The right one is we implement as human beings. If you want to save a drowning person, we will also do something like that. This is called principle of least action. Principle of least action means we are trying to do something in the least time possible. There's no concept of wastage. This one inanimate object, that one is animate as human being. Human being, that one inanimate. In both examples, we are trying to realize principle of least action. Okay. Okay. Now, if we now go into we zoom in into what constitutes this ray of light. Okay. So if you look into the ray of light, and then you have, for example, this laser, and then you imagine you can decrease the intensity of this laser slowly until there's only one pulse containing one particle of light at one time. That means already become very, very less intense. One pulse only contains one photon. One photon is the unique particle of light. It's called a photon. So to make that study on if you have light that actually is being reflected, it will make a decision to have the shortest time taken, which means it has to bend. If you look at the individual particles, the study has now shown that it has been programmed by a super being in our sense of Wasmotuna. Before it goes from that point bottom to north up there, I said north is up there, and that point the south is at the bottom. So it's trying to say it's going from here to that part at the bottom. it has calculated all possible paths. And it will probably choose the one with the least time. That's the principle of this action. So beginning to be bizarre. It's actually calculating. They are calculating all possible paths so that you can reach from the bottom to the top. And then in the classical world, we see what we saw just now. The ray of light is actually a combination of many photons. So when you reach the boundary, it will bend. So what really is happening at the particle level? This is what's happening. They are all calculating, computing very, very fast, and they know that which is the one which is the least action or least time taken. So that is what we call infinite path. So the breakthrough recently is that the study find that cells may compute faster than today's quantum computers. This is a breakthrough. Oh. This is March 2025. Today is a breakthrough result. It's trying to say these things. This is the summary. First one, cells may process information using quantum mechanism far faster than classical biochemical signaling. So it's actually quantum information in the cell, okay? Number two, super radiant quantum effects in protein structures called tryptophan, enabling picosecond scale information transfer in warm biological environments. So if you look at IBM or D-Wave, the one that we have today, is based on fast optoelectronics kind of thing. You need to cool down. You need to cool down and then have a normal environment. Okay? But this one is saying that it's already there. It's already in the cell. You don't need a super kind of low temperature. Okay, it's very, very fast. And then number three, that eukaryotic cells may perform quantum information processing with robustness and speed that rival quantum error correction methods. So what it means is that we, okay, plants, human beings, plants, and even according to this study, you have cellular-based organisms, including bacteria and algae. They don't have brains, can do quantum information processing. So now to make the link, the photon just now is making all fast calculation to make the least time decision. So there's a lot pre-programmed for that particular makhluk. But this one also now is saying they are all programmed. We are all programmed. We don't need what we call it, organism with brains to have this, because as I say, bacteria, they also have this kind of cells, algae. So the main effect that breakthrough is found out is associated with this special kind of amino acid within our cell. It's called tryptophan. Okay, so that means, whether you realize it or not, quantum computers already many years already. Yeah. But we have been looking at the wrong direction. Because we are looking at it from the perspective of hardware, semiconductors. But Allah SWT has shown universal. Look at yourself. That's why it's trying to tell us in the Quran. Look at yourself. And we discovered this. It's actually bio-based. Bio-based. That's how Allah created us. Bio-based. Okay, so quickly, see, don't have much time. So when we go back to the knowledge hierarchy model, this actually redefined the concept of intelligence, my friend. What's intelligence? Data, the information, the knowledge, intelligence, wisdom. And then for us Muslims, we're talking about akal. What is akal? Based on this kind of discovery, what I have shared just now, we seem to be getting nearer, I hope, if I don't confuse you, that akal here is beyond that intelligence and wisdom that we understood previously. When you combine intelligence and wisdom, we are talking about higher order thinking with accountability. Make it simple like this. If you look at intelligence, you are talking about looking at the end. What is the objective, final thing that you want to achieve? But if you are looking at the wisdom part, we are looking at the means. You need to balance. Does the end justify the means? That's it. That's it. So if you're talking about akal, okay, we have to go with this HOTA, higher order thinking, and with accountability. Because now I was trying to understand before this, how did the Hupu bird, Burung Hudhud, to be able to communicate with the Prophet Sulaiman, and even the ants, they have that intelligence, they are able to think, but they don't have the higher order thinking and accountability in the context of we have been given this special thing, gift from Allah SWT, because we are vicegerents. We are not just the we are not just the servants of Allah SWT. We are servant plus Khalifa. That's why Allah gave us the akal. Akal means that you are able to have the accountability, okay, to innovate and discover. You cannot have that in the Hupu bird. You cannot have it at end. But we as human beings are able to innovate and discover. That's the gift. So I want to conclude. We actually have 3 brains. There's nothing surprised about this. Octopus have 9 brains. Mosquito have more than 1 brain. So why are we surprised we have 3 brains? But when we are doing the artificial intelligence, we are doing only 1. We are actually trying to simulate the brain here. But we have the brain here, the here, and then the stomach. The number of neurons in the main head is about 86 billion neurons. The one that we have in the stomach is 100 million neurons. The one we have in the heart, 40,000 neurons. So when we make all this connection, the Prophet ﷺ reminded us that the most commanding influential organ in the human person is the heart. That 40,000 override the 86 billion and also the 100 million neurons. Okay? Because in the end, after all the computation, the stomach brain is to make sure we survive. The brain in the head is to make sure that we do the calculation, but the decision is here. The physical heart, for example, if you do, has been reported several times, if you have a heart transplant, the donor of the dead person heart goes to a new recipient. That person may crave for something that he or she never dreamt of before. For example, KFC. Suddenly, the person who received the new heart wants to eat KFC because that person who died loved KFC. It's a fully functional brain. Here, and here. So, a lot of things to be done as far as artificial intelligence is concerned. The one that I'm trying to connect here is that once we do this, look into this, but within the context of quantum information processing, within the context of bio-based, okay? So all the cells that we have apparently without the brains, they are doing very fast computation to ensure that you follow the principle of least action. No wastage. No wastage. The one with the brains, it depends on what brain I'm talking about. If we are talking about the heart, that one you have a choice. They have a choice. They want to actually become a good person or a bad person. So if we are talking about all this, the framework of the outline I gave just now at the beginning, we have basically touched what is quantum technology, the principle of this action, whether quantum technology is realistic. Yes, Allah has shown us. Yeah, we are still grappling with it because we are not using bio-based. And then how can quantum technology contribute to ummatic excellence? So we need to understand the first revolution has already contributed a lot. Whatever we use, the social media, whatever, it's already the first revolution has demonstrated quantum technology in the first version. It has contributed a lot. Second version definitely will contribute a lot because you're talking about something very fast. Okay, so we need to relate all this so that we package it. How do we relate it to ummatic excellence? Ummatic excellence here means we have to look at it from the point, just like quantum theory just now. Individual and collective. Individual and collective. Individual, we have to realize individually that we have given this special gift akal, and that is to solve a lot of problems, to bring ourselves closer to Allah subhanahu wa ta'ala, to bring others to Allah subhanahu wa ta'ala, our students, our colleagues, bring ourselves closer to Allah subhanahu wa ta'ala, adversaries also. And then collectively, we want to make our society to also acknowledge how to optimize akal and how to bring ourselves closer to Allah subhanahu wa ta'ala. So, briefly, I brought this book. It's called Mission Economy. It's available in Malaysia. You don't have to wait too long to get order. Mission Economy basically is telling us a moonshot project. It gives you an example of Apollo 11. What is Apollo 11? Apollo 11 is to send man on the moon and bring him or collectively many men back to Earth. That is Apollo 11, and it's a moonshot. That's why it's called moon, to bring man on the moon back safely on Earth. Moonshot project. 6 characteristics according to this book inside that moonshot project. Okay. Number 1, you must have a vision. Okay. It's actually with a strong sense of purpose. Imbued, it must be driven, strong sense of purpose. Number 2, you must have what we call as risk-taking and innovation. Number 3, organizational dynamism. Number 4, outcome-based financing. Let's look at the long-term effect as well. Number 5, it's actually how you actually have a kind of relationship. The concept of government, there must be the government, private sector kind of arrangement. Okay, so there's another one also. What is it? Number 6, let's see, play. Collaboration has spillovers over multiple sectors. For example, we take ICT, there are many departments. There are many faculties, many kuliah. So that kind of thing, you need to see how America was able to spend a lot of money. The then President John F. Kennedy made it clear it's going to be very expensive, but they were in the Cold War with the USSR. They sent men to the moon and back. And a lot of, if you look at this book, in all the diagram, the spillovers. You couldn't imagine how the things are benefiting today. Human being. Picture the technology. The computer that we have, they actually go against time to build it very small, so they fit into the module, Apollo. So they all work together. So one day, the president met a janitor in NASA. What are you doing? I'm sweeping the floor to make it clean so that it makes man goes to the moon. So you can relate. The janitor can relate that mission to something of important to the nation. So I'm just giving you an example. But the good thing is our Prophet Sallallahu Alaihi Wasallam has done even better than this. Moonshot. All the 6 things are already there. What I mentioned to you, this has been done. So what are we doing? So the answer is already there. Ummatic excellence is there. And how do we, in this context, because I'm talking about quantum technology, I already made my case. The first revolution has changed everything. Second revolution, definitely. More efficiency, faster. We're talking about 6G, 7G, whatever. It will happen. So, wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
All right. So thank you so much, Prof. Rizal, for enlightening it. I think it's quite a jaw-dropping things to me because there are certain things which I were expecting to learn from, but I think it opens a new dimension now. And I'm quite shocked about the recent discovery about the ability of cells to do quantum information processing. So because before this, we were just thinking about optics and photons and things like that. So and also you conclude with the fact that mission is something very important. And the technology, it seems to me that they are just enablers. So what probably you are still missing is the proper mission to make our Ummah more excellent. So big task before us. But maybe some additional things which, because the world seems to be getting more and more chaotic nowadays, especially with the tariff and trade wars. And so where things is going to start in terms of making things better, and who's going to start the leadership?
If we look from the perspective of prophecies, we are going to the phase of chaotic situation. But it has been promised it's going to be stable before the hereafter, the day of judgment. After that, that's it. But since we are going through this phase that has been prophesied, it's going to be chaotic. And some kind of savior coming along. But we cannot abandon our mission, which is the Khalifa for Islam. That's it.
Right. So maybe we can have some 5 minutes for some more questions. Audience in this room as well as online. Anyone?
If I may start the first question, there was some worry about that quantum computing can calculate the cryptocurrency mining very fast and solve the puzzles of crypto. How do you see this issue?
Okay, when we talk about fast processing, when we look at what are the approaches that we have today, we have 3 options currently on the table, on the plate. Number one, what I showed you, one of the photos just now, they call it quantum key distribution, using quantum physics to find quantum physics. So you have quantum computer using quantum physics, you have quantum key distribution or quantum cryptography using quantum physics. So you can protect your information from being hacked. Okay? Because if you prepare your information in quantum states, one consequence is that it cannot be cloned. You cannot copy like classical information. You can copy. You just take part of the information as a flat, as it goes from Prof. Akram to our friend, brother here, name brother? Yeah? Jamili. Okay. Okay, it goes to you. I just see in the middle and yeah, I siphon some of it. But in quantum, you cannot do that. If you do that, then you are actually contradicting the law of physics. So there's no such thing as cloning in the quantum world. So you don't allow cloning, and then at the same time, any sort of disturbance measurement, you will destroy the states. Okay, so there's a very powerful way to protect. Number one. But the problem is, if you don't use quantum-based, bio-based, you can go, for example, 200 kilometers along the optical fiber. So what's the point of having only 200 kilometers if you want to communicate between your what we call Wisma Putra embassy branch in London and then Wisma Putra you can have, which is more than 200 kilometers. Current limitation to quantum key distribution. Okay, you cannot do that because you don't really know how to do quantum memory yet. Current technology. Quantum memory, Allah has already created bio-based, but electronic-based, you don't know. Okay, so that's solution number one. Solution number two is some of our colleagues, for example, University Petra Malaysia, UPM. Okay, they got the budget from budget 2025 announced recently that they are approaching it using a more complicated mathematics. It's called post-quantum cryptography. So there's another method to try and pull off this attack using mathematics more complicated than what we have today. And then the third one is using what we call digital quantum key distribution. This one you don't need ultra-fast hardware-based optoelectronics. You can use software. So if you're interested, you can talk to me. So three approaches.
Anyone online who would like to pose any questions? There are some questions. It has been shown that Microsoft has been offering AI services to IDF, and these AI services at the same time are using quantum technology. Do you think quantum technology will be weaponized in the future?
Yeah, possible, because technology depends on the brains and the heads that are using it. So just like a knife, simple concept, knife, the technology coming up from steel, you can use the knife to cut vegetables, or you can actually use the knife to kill a person. So it goes hand in hand in that sense. So we shouldn't be surprised, but that's the beauty of Islam, because when Allah sent this message, the beauty message of Islam is actually to guide human beings, to guide our brains, to guide our hearts, to guide our stomach, so that when we make decisions, it's for the betterment of the universe, of our planet Earth, not to destroy it. But along the way, people will know that it can also be able to use to destroy it. Yeah, clever, right? Yeah, given the choice.
Is there any other questions before we end?
Baik. Prof.
Jadi European kan? Senin.
Supreme Court. I was reading somewhere saying that if you use, due to the uncertainty principle, you've got to run the program many times in order to get more accurate answer when you use quantum computer. Then avoid human time for that. And then you mentioned about Ummatic accident. Just came across my mind. we have still no in script, not in script. Faculty without walls to bring the Ummah together. I tried to open the experiment. No, it's not successful. The nature of human being, when we left faculty department, we want to be isolated. So, and how to solve this problem so that we reach the Ummah activity.
Okay. Very interesting. Two questions.
Yeah.
Okay. The first one, what I didn't mention to you, but you may have realized, is that when you use quantum physics to come up with this kind of technologies, you have a new form of mathematics coming in. So the main new thing about this is everything is about probabilities. See, when you talk about that photons going to make a decision to go from point B at the bottom to point A at the top, it makes all the calculations simultaneously. Is this the right one? Is it the right one? Okay, it has to be done simultaneously. Everything has a magnitude of probability. So quantum physics means there's no certainty anymore. Deterministic is gone. Now you're talking about probabilistic. So some of the scientists are happy with this. Nobel laureate, I think we talk about Albert Einstein also not happy, probability. But he was arguing with Niels Bohr. And Niels Bohr told him, don't tell God what to do, because he dies. Niels Bohr, the proponent of quantum physics, said, don't tell God what to do. Okay. To me, as far as I'm concerned, I'm very open. If there's a new discovery, we'll look at it. But as it is, whatever discovery made by quantum physics, experiments to support it seems to be working. Okay, and the main contention of those people are not happy about probability is this. You think you're so great that you want to know everything. If I take this bottle, I put it behind me, I know where exactly it is. But you have to guess. So don't play God. When you are saying that you are God, then you know everything. So there are theories, وَمَا أُوتِيتُ مِنَ الْعِلْمِ إِلَّا قَلِيلًا. That means Allah SWT only give you little. So when you know that you cannot go beyond the uncertainty principle, doesn't mean that that theory is useless. It just tell you submit to Allah SWT and continue to discover. If you have Allah challenge you, go and discover if you have found something better. At the moment you prove very well, okay, you have limitations as human beings. So Allah SWT just open up certain things to bring our closer to understand the inner working of the universe. But it doesn't give us everything. So that's number one. And number two, I have first-hand experience in India. I was invited to a conference in India. So that was the birthplace of the famous Nobel laureate, Rabindranath Tagore, poet, Indian Nobel laureate. So he introduced the university at that place. What's the name of the place? I forgot. But I have to travel from one city. I think it was Mumbai. Or Bombay last time. No, Mumbai. Goes to that remote area. Take a train. I have to sleep in that train. Something like third class. I just came from Kuala Lumpur. Overnight train, the third class. Sleeping there. I think they brought along chicken also. And then when I reached that place, Santiniketan, that place, Santiniketan. You understand what it means to have no walls. No walls. It's a university. And you have the university. Rabindranath Tagore idea was to, maybe I know Ibrahim got the idea from me. Well, I was there. I know. So, yeah, when a conference, you do it like that. And even when you have lunch or dinner, break, tea break, you have all nature coming back to you. You have the babi hutan, the anjing, also having lunch with you. Right. And then they are studying, for example, under the tree. The concept is there. First hand idea. Tapi, yalah, maknanya we are also correct. Ini human beings, they do have their own structure, lecture, halls and all those conference venue. What I'm trying to say is they allow all these natural habitats, animals to come in. And you can also study under the tree, if you like. So I have first-hand experience, I know. Sampai tempat tu pun macam apa. Tapi balik I naik better first class train lah. Tapi masa tu student tu bawa supervisor tu. Just to reach there in time.
Let me to say that if there are no walls, other problem will occur.
No. You can still study. No problem. It's not an issue. But here in Malaysia, we do have an issue because you are going to sweat. Sweating the weather. So you're subjective to insects. Depends.
Okay, my intention is we at this KIUB started we having a meeting or meeting with fellows from our community, looking at quantum knowledge. You know, we need to have collaboration with other, all the knowledge. At the end of the day, the knowledge, every knowledge will be at the top. But we in the university center having a discussion, meeting, that kind of thing. I don't know. Yeah. Say you can until you can coming here and going back.
Don't go back.
Yeah.
Don't go back anywhere.
The opportunity to have a broad discussion with anyone of every knowledge. I don't know whether you get to do that. You have done that in Singapore or not.
It's not easy.
Yep.
No, because it's something related to what I at the end of my presentation just now is related as a mission oriented approach. And I talk about this book, it's called Mission Economy. Mission economy means you have to mobilize the masses so that they understood they're going to the next level. So in our case here, even at the level of the IUM, university level. So how far have we actually managed to mobilize the community so that they support one particular mission? So that the janitor, the cleaner, all essentially saying we are supporting this mission. So very interesting book because it's saying that one of the problems with government, this person is talking about the approach in terms of government. The government need to change. Because one example given here is that government love to outsource. Love to outsource. Many other things. And then they think that they just come in when you need to actually stabilize the situation. But they need actually to have a bigger role and not to leave everything to the private sector. This is an approach that she's saying that was happening in the upper lower level.
Yeah, even in our case, my grant, and we have problem with my grant program. Yeah, the problem is there are many departments. One of the departments didn't pay to the vendor the money. So the issue is that, yeah, so we are waiting for that department. One thing in outsourcing, we have so many system analysts, yeah, programmers in this department. Engineers still alone. If we collect all together, and if we close down the computer department of all the university, maybe we have more than 1,000 computer scientists, but they go for outsourcing. And we program and system they outsource. So the computer scientists in all the department, outsourcing managers. Yes, not really a coder. I want to mention to see the use of. Why don't we close down all the computer department of all university and setting one activity? And we didn't say anything. It's okay, fine.
So, Prof, in this university, we pay for the managed services. What kind of stuff do they, handle the services? But they have this for managed services. We have to get the company to do the services. So we are paying our staff for what? I don't know.
Yeah, so I think that's the time that we have. We wish we can have more time, but I think taking the point from Prof. Tengku, maybe we can have more of this kind of series of discourse, which I think will open the opportunity for us to open our mind and be up to date with some of these important discoveries and also new way of thinking, inshallah. So I think maybe there's something we can do in order to bring this to another level, inshallah. So I think with this, thank you so much, Prof. Rizal, for sharing the knowledge with us. And also thank you for the Kuliah for hosting this event, inshallah. There will be more future intellectual discourse coming. So let's end the talk by reciting Surah Al-Asr as backup for us.
Yeah. Appreciate something.